Alright, here we are again on the second part of the blood type worksheet, or what does it mean when the nurse says she's just not my type? Okay, well, there we go. This is what we could be talking about. So, on this one, we're talking about inheritance of blood type. So, first of all, we start with the first parent. We have one parent that has type O blood and one that has type A blood. Alright, first thing I want you to do is to draw a line across the middle. Oops, I did so good for a second there. Okay, cross right there. Okay, and you could do this on all of these probably. If you prefer, you could draw a line up and down like this to separate the A and the O and the B and the O, whichever way you prefer to do it. And really, we just need to do it in that first blank. I don't know why I did this other blank. Yeah. Okay. Anyhow, so here we go. So say we have first parents. We have type A. Well, if someone is type A, all right, first thing we need to do is what would their possible blood type be? Well, they could be, remember they have two letters for their type, so they could be big A, big A. Or we know that big A is dominant over O, and so it could be big A, O. Okay, either way they would have blood type A. All right. Now, for the other parent, we know that they are type O blood. Well, the only way you can have type O blood is if both of your letters are recessive or OO. So that parent has to have that blood type. Okay. Now, on this part about the genotypes of the children, let's think about that for a second here. All right. Well, what combinations could they have? Well, from this letter person, they could either get this parent, they could get an A, or they could get an O. From this parent, guess what? They could only get O. So really the only blood types, and like I said, you don't really need this line here, my bad on that, is just you could have an A from the first parent and an O from the second. Or you could have an O from this parent and an O from this parent. And really that's the only combination you can have. Alright, let's put that above the line there. Okay. What about OA? You said you could have an O from this parent and an A from that parent, but OA and AO are the same thing. You have an A and an O. It doesn't matter which order. We always put the A or the B first because that's the blood type it is, because it's dominant over O, which is recessive. So we always try it that way, but really AO and OA are the same thing. All right. Now, what blood types are possible? Well, we know the genotypes that are possible. This would be like the phenotype. What do they look like, or what do they have? In this case, it would be blood type. AO would be type, that's correct, A blood. All right. OO would be type O blood. All right. Now, over here, it wants to know which phenotypes or blood types are impossible. Well, there's only four, and they're either possible, which is these two, or they're impossible. All right. And so that means type B. If this mother was to have a baby with B blood, there's just no way that could have happened with this parent. Okay, so that would not be correct. And the other thing that's impossible is AB blood. All right, so between these two columns, they will have these four blood types. So they're either possible or they're not possible. So in this case, A and O are possible, B and AB are not. These used to be, before all the genetic DNA testing, things like that, were used to tell if someone could or couldn't be the father of someone. Now, it didn't prove that they were. Okay, so for example, if you had a baby that had type A blood, a parent that was AO or OO could be the father. The mother was not usually in doubt since she just had the baby, but all it could tell you is someone could be or someone couldn't be. It could definitely rule someone out. In this case, if someone had type B blood, then obviously he was not the father. All right, but it couldn't prove for sure. Say someone had A blood, it couldn't prove that he was the father. It could just prove that he could be the father. Okay, so it used to be in paternity, things like that. All right, the next one's kind of similar, so I'm going to skip that one. I'm going to go down here to A and B, because that one's going to be a little bit different. So let's try that one. We're going to draw a line down the middle here. I like that better, I think, than the other way. Whichever way makes you feel better. All right. So let's go with, first of all, with the person with A blood. All right. We already have done this. We know that if they have type A blood, they could either be AA, because we're not talking about Alcoholics Anonymous here. We're just talking about they could be big A, but they also know that big A is dominant over O, so it could be big A, O. All right. Now, for the other parent, they have type B blood, so we know they have to could be BB. That would definitely have to be type B blood, or once again, because B is dominant over O, BO. We know that AB wouldn't work. That would be AB blood, and we know OO would not work. All right. So now let's talk about the possible genotypes of the children. All right, and we go back to our lesson here. We got one letter from this parent, one letter from this parent. So first one, we could have an A, obviously, from this parent, and we could have a B from this parent, and that would give us type AB. All right. We could have an A from this parent, and instead of a B, it could be if this person has type B blood, they have an O, so it could be AO. All right. It's a possibility. Now, the only other letter this says if this person gave an A, it could be AB or AO. Now, if this person gave an O, it could either be BO or it could be OO. So that is also possible. So if you want to look at possible blood types, if they had AB with their genotype, their blood type would be AB. If they were AO, their blood type would be A. If they were BO, B is dominant, so the blood type would be B. I already said that, didn't I? All right, BB. And last but not least, if it's OO, the blood type would have to be O. So, with one parent being A and one type being B, you could have any of the four blood types would be possible, and therefore the impossible blood type would be none. There would not be any blood type that's not possible in that particular combination. And so if you would just continue to do the rest of the chart using the same general principles, then you'll be in good shape. Alright, now we're going to talk about the bottom of that page before we actually go to the page that has these kind of squares on it. But down at the bottom, it gives you two columns. You have a recipient, alright, recipient, which would be the person receiving, and then you have the donor, which would be the person giving the blood. All right. And what we want to know is, would it be possible or not? Here's the thing. The recipient can't be getting any antigen or blood marker like A, B, or positive that he doesn't already have. All right. Let's look at the first example. We have someone with A negative blood, and we want to give that to someone that has B negative. All right, scoot that over to where it should go. All right, so we're giving B negative blood to someone who is A negative. Well, negative means there's no Rh factor. This one has no Rh factor, so that's okay. But if we're giving someone with A blood, B blood, is that going to give him a different antigen? Yes, it is. That is correct. And the new antigen is going to be B. He does not know that, so he's going to attack it. According to your instructions, you should put a C saying that is going to clot. Okay? So that one is not good at all. Alright? Now, the next one, we're going to go down, number 3 here, is AB negative. And you're giving them A negative. Alright, so if we just compare these two real quickly, if we're giving A blood to some blood, do they already have A markers on their blood or antigens? Yes, they do. So that's a problem. This one has B, but I'm not giving you B, so that doesn't affect it. They're both negative. You can never give a positive to a negative, because that would be a new Rh factor antigen. So this time, instead of clotting, we can say that it's going to be S for successful. Alright, so number 1 would be clotting, number 3 right below it would be successful. So I'd like to go ahead and continue and do that for the rest of these. Alright, which brings us to the back page. Alright, now on the back page, this is kind of we're talking about paternity, and hopefully you'll never go to a hospital as mixed up as this. Nowadays they tend to try to put scanner codes and everything else on people, they don't usually mix up the babies, but it has been known to happen. There have been people who have known to come home from find out 15, 20 years later that, oh, guess what, your babies were switched. Very rare, but it does happen from time to time. But anyhow, in this case, we have 4 blood types of the babies. The babies we know are these blood types. We know the blood types of these, A, B, O, A, and B. One of each blood type. How handy. But that helps us a little bit, at least. Now, it wants to know eventually which baby belongs to which set of parents. Now, we're just going to do this one as parent 1, this is parent 2, this is parent 3, and parent 4, because that way it'll work out nice because we've got the right number of things that we will need to do it. So let's look at the first one. It says parents 1. We know that they have type O and type AB. So what letters would they have for those blood types? Okay, well, if one parent is AB, we know the letters for that one have to be A, and then the second letter would have to be B. So that was pretty straightforward. Now for the type O parent, we know one letter would have to be O, and in order for it to be the other type O, or recessive on both, it would have to also be an O for that one as well. And for some reason my O doesn't want to type. There we go. Alright, now if we did our Punnett square, we know this would be A, O. This one down here would be B-O. That's not a very nice thing to say about him, but there you go. This one would be A-O. And this one over here would also be B-O. So those are the combinations. So basically, this parents could have had a type with AO, which would be what blood type? A. And BO, which would be B. So they have either the baby with A or B blood, but we don't know which one's which. So what you have to do is do this for each parent. Now if we go to the next parent, parents 2, they have AB blood and B blood. First box for you, we know that a parent with AB blood would have to be AB. But this one could be, to have type B blood, could be BB, or it could be BO. So we're going to have to do this one with AB, BB, and figure out what blood types are possible. This one's going to be AB, but this time it's going to be B and O to see what blood types are possible there. Okay, and you'll do that for all 4 parents. Once you get that, you should start being able to find out, well, these parents had to have a particular baby. And then if they had to have had that baby, well, then this one had to have had this parent, and you should be able to narrow it down from there. But go ahead and do all Punnett squares for all 4 of them, and then you should be able to start seeing which parents have to go with which baby. If you have any questions about that, of course, you can feel free to email me. And I think that brings us to the end of the road for this one. So have a good time. It's Easter afternoon, very bright sunny day. So have a happy Easter. Hope you already did by the time you see this, and au revoir.